In this video, we're going to take a look at oxides, specifically metal oxides and non-metal oxides, and some of the reactions that occur. Let's start with metal oxides then. So metal oxides are formed from metals reacting with oxygen. Okay, remember this is a type of synthesis reaction. Could also be considered combustion though, because we are reacting with oxygen. Now, for example, if we have iron, iron reacts with oxygen and forms rust. And depending on which valence the iron has, it can form either FeO or it could form Fe2O3. So there's a couple of different products that we get with iron when we react it with oxygen. Non-metal oxides are formed when non-metals react with oxygen. And so again, this is a type of synthesis reaction, although you could also consider it to be combustion. So an example of a non-metal forming to form a non-metal oxide would be sulfur reacting with oxygen. Now, we can create products here that could have multiple different valence states for the sulfur, but we're just going to focus on one here. So we're going to keep it really simple and just say sulfur reacting with oxygen is going to make sulfur dioxide. What's interesting then is if we take these metal oxides and place them in water, we actually see some different results based on what we're reacting. So let's look at metal oxides first. When we take a metal oxide and react it with water, we're going to produce a metal hydroxide. And remember, hydroxides are bases. And so what we end up with is a solution that's very basic. So for example, if we took our iron 2 oxide that we created in our last example and we react it with water, what we're going to get is an iron 2 hydroxide, which would be basic. So if we tested the pH would be greater than 7. If we take a non-metal oxide with water, then a non-metal oxide reacting with water actually does the opposite. It forms an acid. And the acid's made up of hydrogens as well as the polyatomic anions that are composed of the oxygen and the nonmetal. So let's take a look at what this looks like in an example. If we take our sulfur dioxide, which is our nonmetal oxide, and we react it with water, really what we're doing is we're just combining all of these elements together. So we've got the H2 here, which is now at the front because that's where it shows up in a acid. And then we've got our sulfur and our sulfur here. And then finally we have 2 oxygens plus 1 here, so that makes 3, and that's where our O3 is coming from. So really it's just about combining all of those elements together into the acid. And then of course you would want your AQ state symbol to come in your equation afterwards. So we can look at, and what's really interesting is looking at the trends of oxide as we go across a period in the periodic table. If we look specifically at period 3, then we've got sodium, magnesium, aluminum, silicon, phosphorus, and sulfur. We've got the formula of all of the different oxides here. So Na2O, MgO, Al2O3, SiO2, P4O10. This one's a little bit weird, but that's how phosphorus makes its oxide. And then a couple of different forms of our sulfur oxide. Now, if we take a look at the nature of the elements, so that means this element up here, then sodium, magnesium, and aluminum are metals, and then silicon and phosphorus and sulfur are nonmetals. In terms of the oxide itself, sodium and magnesium are both metal oxides, so they would be basic. Silicon, phosphorus, and sulfur are nonmetals, so they would make acidic oxides. And aluminum's kind of weird because aluminum sits right on that dividing line between metals and nonmetals. And so it forms what we call an amphoteric oxide. And really, what that means, and we'll come back to this term later on in another video, is that it's going to have properties of both a basic and an acidic oxide. What's really interesting about this oxide then is it doesn't react with water, but it does display that amphoteric behavior because it will react with both acids and bases to form salts. So, like I said, we'll come back to this term later, but that one is really kind of an interesting one in terms of its properties. Now, in terms of reactions with water, sodium and magnesium react with water, as well as the phosphorus and sulfur. Silicon actually is insoluble, so it also doesn't react with water. The magnesium one oxide is only slightly soluble, so you get a little bit of reaction, but you don't get an entire reaction. And then finally, the solutions formed. We have for sodium, it's alkaline. For magnesium, it's also alkaline. So that's because these are our metal oxides. So they're making basic solutions. Aluminum and silicon don't dissolve in water, so they don't make anything. And then phosphorus and sulfur are our non-metal oxides, so they make acidic solutions. Finally, the last thing we need to take a look at in this video is our reactions of our oxides. And these are ones that we just kind of need to know in order to be prepared for the IB exam because they are fair game. The first one, sodium oxide reacting with water is going to make sodium hydroxide. That one's pretty easy to come up with because it's following the rules that we've seen in previous videos as well as in the last few slides earlier in this video. We've got magnesium. Again, MgO reacting with water is going to form magnesium hydroxide. So that one is straightforward. Now, phosphorus is a non-metal oxide, so P4O10 is going to react with 6 waters, and it's going to make H3PO4, or phosphoric acid. Sulfur, we've got sulfur dioxide, really kind of one of the main ones that we need to know. Reacting with water is going to form sulfurous acid. Or if we took sulfur trioxide reacting with water, that would make sulfuric acid. Now, the last one you do need to take a look at is the reaction of nitrogen oxides with water. Nitrogen itself has many different forms of oxides, ranging all the way from N2O to N2O5. The two of the more important ones for the environment are NO and NO2. And NO is oxidized in the atmosphere to NO2. And so NO2 is like really the main sort of nitrogen oxide that it has an impact on our environment. And so if we took this NO2 and react it with water, it's going to form both nitrous and nitric acid. And nitric acid is actually one of the acids that is responsible for acid deposition, which again, we're going to come back and take a look at in a later video. That's it for this video then. Let's move on to our next task.